Good morning. So this is April 5th, 2024, and there was just a moderate sized earthquake in New Jersey. And this is kind of a nice opportunity to see the um, some seismicity on seismic stations in the UP. It's big enough that we can see it on our stations, a few hundred miles away. Um, but it's a little bit hard to see. So I'm just going to show you quickly how you can find that earthquake in your data. And in case you want to show it to your class, this is probably one that's going to make some national news because of its location. And it's rather unusual to have a earthquake in New Jersey. Okay, so you can see here, this is the USGS page for this. And what I'm going to do is just go to um, Shake Map. Station View, stationview.raspberryshake.org. And this will have, um, I've got it centered on our location here. So these are upside stations that are currently running. That little window that popped up there tells us that they're having some problems, and they have been for the last month or so. Haven't been having problems with the server, but they're still working on it. So anyway, but we can see earthquakes. So now the stations are showing up as these hexagons, and they're colored depending on the level of shaking that they're experiencing right now. And as you know, most of these are in buildings and are in places where there's a lot of cultural noise. And so um, some of that noise is just from people walking around or traffic or other things. But there's also earthquakes on here, like this little one up here in Ontario. Here's another little one in Ontario. And you can actually click on these earthquakes. But I'm going to go down to New Jersey and click on this earthquake that just occurred. And we can see it there. And the cool thing is now if I add or click on a station, I'll see the seismic recording at that station. So here's somebody's Raspberry Shake. Don't know anything about this, but if I click on this, you can see that it's 29 kilometers away. And we get the plot of the seismogram there and then the spectrogram here. The seismogram, at this scale, it's a little bit difficult to see a lot of detail, but clearly we get P wave here coming in first, and then the S wave is this larger amplitude that comes in right after it. And at 29 kilometers away, the difference between the arrival time and the between the S wave and the P wave is only a few seconds. So that S wave's coming in shortly after the P wave. If we move, let's say, up into New York, now we've got a little bit more separation between the S wave and the P wave. So the first P wave comes in here, and then there's a lot of scattered energy. And then the first S wave comes in here, and that nice large S wave amplitude shows up well on the station. In the spectrogram, we can see that this P wave has a pretty broad frequency, pretty broad range of frequencies, up to, into 30 hertz or so. And a really nice example. Earthquakes in the eastern US tend to be less attenuated and easier to see at stations that are farther away. Okay, so at 180 kilometers, we've got a S minus P time difference between the arrival time of the S and the P of something like 20 seconds or so. Now let's go up to the UP and see if we can see this event. So I'm clicking on station at the Eastern UP ISD, and there it is. The amplitude is a lot lower. So these are in microns per second, 5 times 10 to the minus 6, so that's 5 microns per second. So it's pretty hard to see. It's a little bit easier to see it in the spectrogram. Oh, and then you can move on to other stations here. Again, you can see there's these horizontal streaks mean that there's a lot of other kinds of vibrations contributing to the signal here, but they're in the low frequencies here, you can see that earthquake coming in. And the farther away you are from the earthquake, the harder it is to see the high frequencies anyway. So the things you're going to see best are the low frequencies and especially surface waves. Now this little window of time isn't large enough to capture the surface waves. We can use a different approach to find those. And finally, I'm going to look at the station up here in the Keweenaw Peninsula. This is not in a school. This is somebody's private station. They have both a low frequency sound sensor and a seismometer, but so that's what these lower plots are. Those are from the infrasound sensor. But you can see here the seismogram is pretty nice and clean because it's in a location that doesn't have a lot of cultural noise. So when an earthquake like this happens during the day and all these schools have activity, well, our schools in Keweenaw are on spring break right now. So this actually recorded it pretty well. This is the station in the Houghton Middle School, and this actually made a beautiful recording of this earthquake.